So just so you know, I'm recording what we're talking about. That way I can post it on the school website, on the topics page, where everybody can access it, including you all, if you want to go back and look at some of the problems that we're going to do today later on. Our goal today, and actually for most of this week before our test on Thursday, is to learn about freefall and what freefall means in the context of kinematics equations and describing accelerated motion. So before I define freefall, I want you guys to help me with answering 3 questions. And that is that I want to know what the 3 kinematics equations are that we've learned so far. So equation 1.
Velocity final is equal to velocity initial plus acceleration times time.
Good. Kinematics equation 2.
You know okay. Final displacement is equal to initial displacement plus initial velocity times time plus 1/2 acceleration times square.
Great. Anyone want to give me the 3rd one? As a warning, very soon I will start calling on people for these, so you're going to be ready for them pretty quick here. So what do we got for our 3rd equation?
Final velocity squared is equal to initial velocity squared is plus 2 acceleration times the change in displacement.
Excellent. All right. Those are 3 equations that we can use to describe motion. Let's talk about a specific kind of motion, and that is free fall. Free fall is a special kind of accelerated motion. It occurs when we say in what we would describe as an object falling unimpeded. But specifically, we're talking about falling near Earth's surface, assuming that no air is present, so we can ignore air resistance. And such that gravity is the only thing accelerating its motion the entire time. The direction of the object is not important. The size of the object, not important, although we're going to think about things as point particles. But anytime we have an object that is moving under the influence of gravity near Earth's surface, we know exactly what the acceleration is. The acceleration is equal to the gravitational constant in magnitude. The gravitational constant, we use the symbol little g for it. It's 9.8 meters per second squared. Sometimes we put the negative sign in there, indicating that it's downward towards the surface of the Earth. But whether there's a positive or negative sign in there is actually dependent on the coordinate system you choose. So if you say it's negative 9.8 meters per second squared downward, then you must have selected a coordinate system where up is the positive direction. That's not required. You can pick any direction you want for your coordinate system, any origin you want for your coordinate system. But the important thing is that this acceleration, this gravitational acceleration, is always constant, and it's always toward the center of the Earth. Because we are ignoring the effects of air resistance, we have just the pull of the Earth on the object that we're considering, and Earth pulls on everything in a very consistent, constant way. Doesn't matter what the object is, doesn't matter the size of the object, doesn't matter if the object is tossed upward or if it's just dropped. Doesn't matter. Still the same value. That's free fall. So whenever you see the word free fall, we're thinking constant acceleration of magnitude 9.8 meters per second squared. Free fall is kind of fun because the motions are very symmetric. When something is thrown upward and it returns, we're going to describe that with basically what we call parabolic motion. So it spends half the time traveling up, half the time traveling back down again. The velocity when the object returns to the ground is opposite of the velocity when it's thrown upward. So if I take an object and I throw it upward at 2 meters per second, when it comes back down to my hand again, it's going to be moving at negative 2 meters per second. Acceleration is constant everywhere. It's negative 9.8 meters per second squared, no matter where I am in that motion. But free fall starts when I toss an object, when I release an object, when it leaves my hand. Because then it's not being influenced by me anymore, it's being influenced only by gravity. And free fall ends, I'm talking about, say, a projectile. Free fall ends when it hits something else, when I catch it. The instant I've caught it, it's no longer in free fall. The instant a projectile hits the ground, it's no longer in free fall. So, let's go through a few practice problems. We're going to start with an object that is dropped from rest off a 120 meter high cliff. We're going to assume that air resistance can be ignored, and as soon as we say air resistance is being ignored, and we have an object that's being dropped, acting like a projectile, then we know we're talking free fall. What would be a good way to start a problem like this, involving kinematics, and trying to find for, first of all, it says how long. What am I trying to solve for when you see the words how long?
Seconds. T.
Seconds. This is time. Yeah. So I need to find a time value. Any strategies for starting a kinematics problem?
Can list out the variables that you have already.
All right. I've got initial position, I've got final position, I've got initial velocity, I've got final velocity, I've got acceleration, and I've got time. These are my 6 generalized variables. I also probably want to draw a picture. Sometimes drawing a picture helps us kind of organize what's going on. So I've got a cliff here. This is the ground. That's the top of my cliff there. What's the displacement, the difference between the top and the bottom? Yeah, that looks like 120 meters. That's the magnitude of the difference between those positions. This object is being dropped from the top of the cliff. What's its starting velocity when it's here at the top?
0.
How do we know it's 0? What words give us that hint?
From rest.
From rest. That means it starts with 0 velocity. Okay. I can fill that value in now. I know its starting velocity is 0 meters per second. I need to establish a coordinate system. Where's my 0 point for this coordinate system? And what's the positive direction and what's the negative direction? This is all vertical motion, so I'm just focusing on what we would consider maybe our y-axis of motion. Do you guys care where we put the origin for this coordinate system? Do you want it at the ground? Do you want it at the top of the cliff? Somewhere in the middle. Ground. I heard ground first. This is x equals 0 at the ground. Done. So what's our, So what's our starting position?
120.
Starts at 120. What's our ending position?
0.
0. Okay, so we're saying this is 120 meters above the start, so this must be our positive direction for our displacement. Up is positive, down is negative. What other quantity do I know here? I need to know at least one more.
Acceleration.
Acceleration, what's my acceleration?
Negative 9.1.
Negative 9.81 meters per second squared. That would be our most exact value. I'll be honest, when I'm doing problems on the board, I am likely to round off on this and use negative 10. You may use negative 9.8, you may use negative 9.81, you may use negative 10 meters per second squared. That's true on my tests. That's true on problems we do on the board. That's true on the AP exam. There is one exception to that rule in this course. Any idea where we might want to use a specific value? How about Quest homework? Sometimes in Quest homework, because of the sig figs that you need to use, if you use 10 versus 9.81, it may affect your answer. So if Quest problem says use 9.81, use 9.81. Okay? Otherwise, they're all about the same. I would also say that in labs, we probably want to use the most exact value we have available because we're trying to get an exact measurement answer. So we might use 9.8 or 9.81 in lab. All right, how long is the ball in the air? I have 4 of my 6 kinematics quantities. I'm trying to find this one. Which kinematics equation could I choose?
2.
I would go with 2, because 2 allows me to solve for time and requires no information about final velocity. So if I don't know final velocity and I want this quantity, I'm going to go with 2. All right. So position equals initial position plus initial velocity times time plus 1/2 times acceleration times time squared. So final position is I keep doing this. Final position is 0. Initial position, 120, plus 0 times t, plus 1/2 times negative 10 times t squared. Somebody want to solve for t for me?
It's about 4.5.
4.5?
No, 4.9, sorry.
4.9.
Yeah.
Okay. Can I get consensus on that? One other person solve it out? Tell me that's the correct answer. So I should have 20. I'm going to multiply that by 2. I get 240. I get 240 divided by 10. 24. Square root of 24 should be a little less than 5. So I think that sounds reasonable. I want to make sure you all can get to that too. All right. So now I know that it takes 4.9 seconds for this object to get to the ground. What is the ball's speed and velocity when it strikes the ground at the base of the cliff? What's the difference between speed and velocity?
The speed is just
Yeah, it's tough to find these. Velocity is our displacement per unit time. And so in this case, we're going from 120 to 0. Is our displacement positive or negative? Negative, because displacement is always final position minus initial position. So 0 minus 120 gives us negative 120. Our velocity is moving in the negative direction. So because this object is moving towards the negative direction on our number line, our velocity is negative. Speed in one-dimensional motion is always just the absolute value or magnitude of our velocity. In 2 dimensions, it's going to be a little bit more complicated, but we'll get there soon. For speed now, we're just going to take the magnitude of our answer. Sometimes they might have the same sign, sometimes they might have opposite signs. So which equation should I use to find the final velocity?
equation 1.
Sure, let's use equation 1. At this point, I could also use equation 3, but it's got a lot more stuff to do, so I don't feel like doing all that extra stuff. This will get me there immediately, in 1 step. All right, final velocity equals initial velocity plus acceleration times time. Final velocity, unknown. Initial velocity is 0 plus 10 meters per second squared in the negative direction times 4.9 seconds. And so what's my final velocity? 49 meters per second, and that's negative because it's in the negative direction. So my velocity, negative 49 meters per second. Great. If I want to talk about speed, speed is just going to be the absolute value or magnitude of that. So you would say my speed in this case?
Just 49 meters per second.
Just 49 meters per second. So you see that when we're dealing with free fall, we're not introducing any new equations, we're just introducing a new constraint on our motion. The only constraint here is our acceleration is now always 9.8 meters per second squared because it's acceleration due to gravity pulling on an object when it's near Earth's surface. Your acceleration is not always at a value. We did some problems already, like a car accelerating down a street. Then we have a different answer, a different value for our acceleration, but our process is the same. We have kinematics equations, we have 6 different variables, we identify, we draw a picture, we establish a coordinate system, and then we solve. Let's try another one. So, same scenario. Drop a ball from rest off a 120 meter high cliff, assuming air resistance is negligible. What is the ball's speed and velocity when it's fallen? Half the distance. I'm going to erase all of this. Some of this may still be useful. Do we want to change our coordinate system? Are you guys happy with the coordinate system we established already? Leave it the same. Okay. What values do we still know?
We still know the initial and final
All right.
position.
Initial is still 120 meters, but what's our new final position?
60.
About 60.
60 meters. Because I want to know about the object when it is here, at 60 meters. Do I know its initial velocity?
Yes.
I still know its initial velocity, 0 meters per second. Do I know its final velocity?
No.
No, I can solve for it, but I don't know it. Acceleration?
Yes.
Negative 10 meters per second squared. Time it takes to get there?
Don't know.
No, but I know how to solve these now. Okay. If I want to find the ball's speed and velocity when it's fallen half the distance, which kinematics equation should I choose?
Number 3.
3. Why?
Because we don't know the time, but we do know it's the change in displacement.
Right. I know all of these quantities, and I'm solving for this one. If I don't know anything about the time it takes for motion to occur, I'm probably going to go third kinematics equation. All right, so let's solve this one. That means we're going to use the one that's got b squared in it. We can handle it. B squared equals initial velocity squared plus 2a times displacement. Be careful here. What is our displacement?
Negative 60?
It's negative 60. It's very easy to just put in 60 here, not pay attention to the sign. The sign is important. What's our acceleration?
10.
Negative 10.
It's negative 10. I have 2 negative signs in here. If you miss one of them, you're going to be in trouble. If you make a mistake and miss both of them, you're going to get the right answer by accident. That happens sometimes, but I would probably not consider that a right answer. You shouldn't either. 0 squared plus 2 times negative 10 times negative 60. All right, solve for B. Square root of 1200. Yeah?
Negative, well, not negative, just 34.6.
34.6. All right. The answer we get from the calculator, 34.6 meters per second. Should it be positive or negative, though?
It should be negative because
So why don't we get negative 34.6 when we plug this into the calculator?
you can't square root a negative number.
Right. So the way I want you to think about it is that you are smarter than the calculator. Don't let the calculator's limitations fool you. Because when you take a square root here, you're taking a square root of a positive number. But if I square a negative number, I'll get a positive. Just like if I square a positive number, I'll get that same positive value. Your calculator cannot tell the difference between negative 34.6 and 34.6 in this case, because you're asking it to take a square root of a positive, but the answer could be positive or negative. If you were writing this out by hand in an algebra course, your answer would be plus or minus 34.6. The calculator doesn't always see it that way. But you're smarter than the calculator, and you have a picture to refer back to. What's the direction this object is moving? Downward. Downward, that's our negative direction according to our coordinate system, and so we know our answer has to be negative 34.6. Be careful with signs in here, because when we're dealing with velocity, it has a direction. What's the speed, though?
34.6?
34.6. Because when we're talking speed, we don't care which way it's moving, we just care that it is moving. And so we take the magnitude, or the absolute value of our velocity answer. Is that okay so far? All right, so here's what I'd like you to do next. I do want you to sketch graphs of position versus time, velocity versus time, and acceleration versus time in your notebook, or on a piece of paper, or on a whiteboard, whatever you have nearby. I'm going to do the same up here. We've calculated some numerical values now along the way. So you should be able to drop in some numbers onto these graphs too. So I'd like you to try to do that as best you can. Give me a rough estimate then of our position versus time, velocity versus time, and acceleration versus time graphs. Okay, you can do that now, and I'll do that up here too. values were negative, so I want to make sure I have space in both the positive and negative region, but not all of the graphs require both the positive and negative region. They'll have different scales on the vertical axes and different numerical quantities. One thing I know for sure is for free fall, I should have, for acceleration, flat line at negative 10 meters per second the whole time. I know my initial velocity is 0. My final velocity, after I've fallen for 4.9 seconds, what was that? Was it 49 meters per second? Negative. Velocity is negative. I'm going to draw that line completely in the negative region. How about my position? What sort of shape should that position versus time graph have?
It's going to be a kind of like a hill, I guess.
Like a hill.
Yeah, it starts
Like
flat and
curves, yeah, like a parabola. And the question is, does it curve downward or curve upward?
curves downward.
Curves downward. So a few shortcuts here. First of all, the magnitude of the velocity increases with time. So that means that the steepness of the tangent lines to this curve should be getting larger. It should get steeper and steeper, in this case in the negative direction. Whenever you see a negative sign with your acceleration, every time you see a negative sign with your acceleration, the curvature in the position versus time graph is downward, like a hill. If the acceleration is positive, then the curvature in my position versus time graph is always upward, like a bowl, every single time. Now, where it starts and where it ends on there, that's to be determined. But your tangent line slopes can give you information, and the sign of the acceleration can give you information about the curvature of your position versus time graph. Do I know what the slope of this line should be? I don't have any units on there, but if you were to measure its slope, what should you get?
-10.
You should get -10 for its slope. Because the slope of position versus time is always acceleration. And acceleration in this case is constant. The slope of position versus time should always give us velocity. In this case, though, notice the slopes of these tangent lines change as time goes on. Just like the magnitude of our velocity changes as time goes on. Questions about this example? Or is this one okay? I've got one more here for you then. Alright. You throw a ball straight upward into the air with a velocity of 40 meters per second, and you catch the ball sometime later. How long is the ball in the air? How high does the ball go? I remember we might have a few other questions later. Yeah, I guess I renumbered them though. But this is the problem that we're going to address. Give me some strategies for starting a new kinematics problem. What's the first thing we want to do?
List out variables.
List out our variables. Yeah. And if I'm going to name the variables, I'm going to have them in reference to a coordinate system. I always start with a coordinate system to attach to my problem in order to identify and define the quantities that I'm going to use. So I'm going to need to draw a picture. Got my variables here. I'll need a picture. You guys draw some sort of a picture representing what's happening in this problem. My picture is going to look something like that. put the origin from a coordinate system? I could put it here. Put it here. I mean, sometimes there's just like an obvious choice. An easiest approach is to put our x equals the 0 position where the object starts. And then it's going to get up to some maximum height sometime later. I don't know when, but it'll get there eventually. And then it'll come back again to the ground. Do you care which is the positive direction? Do you want up to be the positive direction or down to be the positive direction?
Probably want up to be the positive.
Okay, sure. Up can be the positive direction, but I always want to make sure to include that on my coordinate system, on my drawing, so I can keep track of the information. So what quantities do I know so far?
You know, so I know initial velocity and initial position.
All right, I know it starts at 40 meters per second in the positive direction, which is upward, and I know it starts at the ground.
And
What else do I know? What do we got, Reed?
You know acceleration
I know the acceleration of this object.
because there's gravity.
Just gravity. So my acceleration is
-10.
-10, because it's down.
could
Gravity
you,
always pulls things downward.
could you say the final velocity is 0 since you're catching it?
Oh, I do know the final velocity, but it's not 0. Let me show you why. Okay? So if I've got an object, I'm going to toss it in the air. It's only in free fall while I'm not in contact with it. So it starts upward, it leaves my hand, and then as soon as it hits my hand and I stop it, now I'm influencing its motion, it's not just gravity. So its final velocity is not 0. It'll be very tempting as we start this out for you guys to write 0 for the final velocity. But I actually do know something about the final velocity. Read.
Is it just the opposite of the initial
It is.
velocity?
So because of symmetry for parabolic motion, symmetry for objects in free fall, if it takes the certain amount of time to get to the top, and it takes the same amount of time to get back down again to the ground. And so the change in its velocity going to the top, what's its velocity when it's at the top of the arc?
0.
0. What's its acceleration when it's at the top of the arc?
Just -10.
-10, because it's -10 the entire time. I will try to fool you guys on that question a lot, so watch for it. On the way down then, -40. Here's my marker here. Great. How long is the ball in the air? We now have 4 numbers. That's a good sign. We could probably solve now for a 5th one. Which equation do you want to use to try to solve for, this says how long? What are we solving for? Time. Which one do you want to use?
Number 1.
I think number 1. It's not a whole lot we have to deal with there. Final velocity equals initial velocity plus acceleration times time. Our final velocity is -40. Our initial velocity, 40, plus -10 t. Solve for t. What do we got? It's going to be a whole number.
8 seconds.
8 seconds. Yeah. It takes 8 seconds for this ball to go up, reach its maximum height, and come back down again. Let's break this down. I like using 10 because it allows me to do a lot of mental math to make sure that my answer makes sense. So, I toss this object up in the air. Okay? 1 second after it leaves my hand, how fast is it moving? If it starts at 40.
1 second, be 30.
30. 2 seconds after it leaves my hand, it's moving at
20.
3 seconds after it leaves my hand, it's moving at
10.
4 seconds after it leaves my hand, it's
0.
0. What do we know about 0? What's going on with it when it's at velocity 0?
It's going to be at its peak.
That's the peak of the motion. Because after that, its velocity continues to change. What's its velocity 5 seconds after it leaves my hand?
-10.
-10. And if its velocity is now -10, what's its direction of motion?
Going down.
Down. Whenever the velocity is positive, this object is moving up, and it's moving up until it reaches a point where its velocity has been slowed to 0, and then after that, the velocity is negative and it's moving downward. Notice that means it takes 4 seconds to get to maximum height, and another 4 seconds for us to be back down where our velocity is -40 again, right at my hand, before I catch it again. Does that help? So if I ask the next question, how high does the ball go? I'm asking a question about displacement. But I'm not asking you its displacement over this full 8 seconds. how much time does it take this object to get to its maximum height?
4 seconds.
4 seconds. So when I figure out how high the ball goes, I need to find an equation that has delta x in it that I can use. Which of these will give me information about my displacement?
2 or 3?
I could use 2 or 3.
2 is probably better.
You want to try 2? Let's try 2. All right, so for a problem 2 there, so I'm going to find, final position. And to find final position, I need to know initial position. I need to know initial velocity times time, plus 1/2 times acceleration times time squared. To find my height of this object above the ground, I need to know where it starts. It starts at the ground. I need to know its initial velocity, 40. I need to know how much time it is moving until it gets to its maximum height. It gets to its maximum height at 4 seconds. Plus 1/2 times its acceleration. In this case, when we're dealing with kinematics, our acceleration is constant. Negative 10 meters per second squared times 4 seconds. That's squared. Where is it? It's not 40 meters, which is often our predicted value. Because it's not moving at 40 meters, or sorry, it's not 1600 meters, which is I think the 160 meters. I'm bad at this today. It's slowing down as it rises. Do you have a value, Reed, that you've calculated?
I got
Don't
80.
forget the negative sign. 80. Can I get a consensus on that? Has anyone else gotten 80 for their calculation? Okay, I've got 2. Be careful. You want to? I also get 80. I'm just going to make sure that we're all able to calculate that. Watch the negative sign here. Really easy to forget that there's a negative sign in this term. Really easy to forget that time is squared in this term. That's where I would say that 80% of kinematics errors happen with writing the equation down incorrectly, which is why at the beginning of class I asked you guys to recall those equations for me. Very easy to write them down incorrectly if you haven't practiced them. 80 meters. That's what I get. Now I know that the maximum height this object achieves, 80 meters. As it rises, it slows down. So it doesn't move at 40 meters per second for a full 4 seconds. When it's at the top, it's actually slowed to 0. It's come to a stop. All right. All right, what's the ball's velocity when you catch it? You've already answered this question for me. Negative 40. One thing to note, too, is that if we had used this third kinematics equation, we would have gotten the same answer for displacement. We would have found that the ball is 80 meters away. It doesn't matter which of these you choose, as long as you're consistent in how you define your coordinate systems. All right, so we know our velocity here, or sorry, negative 40, I mean. Like we said earlier. Now, again, I'm going to ask you to sketch graphs. Sketch for me approximate position versus time, velocity versus time, and acceleration versus time graphs representing this motion. And it doesn't matter which one you start with. Your brain may be better at seeing the information from the acceleration to velocity to position conversion, or from the position to velocity to acceleration conversion. Doesn't matter. We have a lot of numerical quantities we can use now. This is 8 seconds total. Seconds. 4 in there. Acceleration, I like drawing that one first. Because I know with Freefall exactly what it's going to look like and exactly what the quantity is going to be. There's no confusion on that one. It's this horizontal line. Because I've set up as positive, this value is negative. Velocity. I know my initial velocity. I know my final velocity. Initial velocity is 40 meters per second. Final velocity, negative 40 meters per second. For that to happen, it must go through 0. We also know exactly how much time it takes for our velocity to get to 0. It's at 0 at 4 seconds. Position versus time. My initial position, 0. What's my final position for this object? At 8 seconds, where is it?
Back on the origin.
Back at the origin. Yeah, it's symmetric. Back here again. Maximum height is achieved at 40 seconds, and at 40 seconds, I'm 80 meters above the ground. Now, this is where I want you to be really careful. What should the shape of my position versus time graph be? Is it linear? Is it a parabola?
Should be a parabola.
Should be a parabola. Don't forget that. Accelerated motion is going to be represented as a parabola. Does this parabola open upward or open downward? Is it like a hill, or is it like a bowl?
Could be a hill.
It's going to be a hill because our acceleration is negative. So it goes something like this. It's symmetric. Parabola. Opens downward. Is that okay? All right. So I'm going to stop here. Just so you're aware, I have one additional problem, and then I have a summary of kinematics. We're at the end of the unit. We're going to do a lab tomorrow. We have some review stuff to do on Wednesday, and we have a test on Thursday, covering kinematics. We have about 7 minutes left in class. I'm going to shut off this video that I'm making for the juniors, and I'd like you guys to open up Quest, because hopefully you can get some Quest